Assalamualaikum warahmatullahi wabarakatuh. And greeting, we are from Group 1. We present about the group project of injection molding BDD 40903. So I am Amirul Adam bin Ismail, AD 170144 as the team leader. And my group members is Ahmad Razik Anas bin Nasri, Ahmad Zahiruddin bin Muhammad, and Amirul bin Fadzil.
Assalamualaikum warahmatullahi wabarakatuh. My name is Ahmad Razi Anas bin Nasri, AD170314, and I would like to present about simulation study and analysis of different runner shape dimensions in mold design by using Mold Flow Advisor. So my part is about introduction. First of all, as we all know, injection molding is an injection process to obtain molded products by injecting plastic materials molten by heat into a mold. Injection molding machine usually contains two parts, which are clamping unit and also injection unit. Five basic process during the injection molding process, which are clamping, injection, dwelling, cooling, mold opening, and also removal product. This study, which is our study process, are about, first of all, the designing mold product. Second, designing runner, the shape of runner, which are trapezoidal, and also the optimization of simulation to run the mold flow product. Our objectives are to compare the effect of three different dimensions of trapezoidal runner shape and also to identify the best trapezoidal runner shape. This is the flowchart of methodology for our project. First of all, start with the selected mold product, which is the air freshener. Then, listing criteria of free mold design, the type, shape, dimension, reason of advantages and disadvantages of runner, gate, ejector, and cooling. Then we continue to the sketching of mold of product. Then design the mold product using SolidWorks, set up the parameter in mold flow, and run the mold flow simulation. If the mold flow simulation is failed, we have to design back in the mold product by using the SolidWorks and set up again the parameter in mold flow software. Then proceed with the discussion and the conclusion, and that is the end for our methodology. For the mold product design, which is with air freshener, as shown in the figure above, uh, these are the title block of design of air freshener, including the dimension and the detailed dimension of the product. The dimensions of the air freshener is 32.28 times 13.55 times 6.77 millimeter for overall. They contain the boss design, reef design, and also the corner radius, which are 0.48 diameter for boss design, 0.32 millimeter width for reef design, corner radius, which is 0.32 millimeter radius. For the material selection, in order to proceed with the injection molding process, we choose the ABS plastic, which is acrylonitrile butadiene styrene, which is a common thermoplastic polymer. The advantages of using this ABS is because it is very sturdy and hard, suitable for machining all car parts, higher melting point, longer lifespan, and also easy to paint. Last but not least, for our software and machine, we use the SolidWorks and Moldflow Advisor for designing our mold product, which is the air freshener, and to run the simulation, and also to design the trapezoidal runner and injection flow simulation. The machine that we have to use to inject the molding, that we use to inject the molding, which is the Nisei MP7F machine as required. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul Adam bin Ismail, AD 170144. I would like to present about the mold design of our project. So, mold design is a decisive factor for the molding success, such as dimensioning and location of the screw gate, dimensioning of shear edge, flow edge, cooling and ejector technique. So in this project, the criteria of the mole designed to be analyzed are the runner system, gate system, ejector system, cooling system, and vent system. Right, so this one is the mole design for our project. Okay, next is the runner system. So in this project, we use the core runner system, and runner shape used is trapezoidal shape. So in this project, the study concerned about the different dimension of runner shape, which is the trapezoidal shape that will affect the to the mold design. So as we can see, the design 1, 2, and 3, they are different between the width and the thickness of the runner. So for the design 1 is 1.25 millimeter for the width and thickness. So design 2 1 millimeter, design 3 is 2 millimeter. Okay, next is the gate system. Okay, the type of gate that being applied to the mold design is called gate, and gate shape used is circular tapered. So for the all three design, we use the same gate, which the start diameter is 1.25 millimeter, and the end diameter is 1.0 millimeter. Okay, next is the ejector. So the diameter of the blade ejector is 1 millimeter. So the ejector pin come in a variety of diameter from the provided catalog, but their reduction is primarily determined by the thickness of the item. Shoulder ejector pin with cylindrical head is used in this design, but refer to ISE 8994. The ejector total is for one cavity will have two ejector pin at the back of air freshener. Alright, so for the cooling system, we use the series cooling, and the type cooling system is circular channel type with diameter of 5 millimeter. So below are the diagram of the cooling system design 1, 2, and 3. Okay, next one is the vent system. So venting is a process that is used to remove trapped air from the closed mold and the volatile gases from the processed molten plastic. So if without venting, the trapped air will compress as plastic tries to force it into the mold, and the air will ignite, burning the surrounding plastic and causing char erosion to the molded part. The venting for a mold design will follow the venting guideline for the depth of the vent that will be used in our mold design. That easy flow ABS material will be 0.0508 millimeter.
Assalamualaikum. My name is Ahmad Zahiruddin bin Muhammad. I am here to present the simulation, the result and discussion. This is the table 4.1, the comparison of data gained in a simulation. And table based on the table, design 3 has the largest runner dimension, followed by design 1 and design 2. In terms of their time to filling the mold, design 2 is the shortest one with 0.543 seconds compared to design 3, 0.5898 seconds, and design 1, 0.7816 seconds. This output proven that the fill time of a mold does not really influence directly to the runner dimensions. Next, for injection pressure, designed to record the highest value with 97.807 megapascal rather than the other two design with 53.832 megapascal and 79.327 megapascal for design 1 and design 3 respectively. As observed in the table, the cycle time for each design does not directly proportional to filling time result, especially for design 3 as it has the largest cycle time 101.73 seconds, but not the target fill time 0.5898 seconds. The factor behind this is the size of runner in design 3 need to consider another process of injection such as cooling time. While for a smaller size of runner, which is design 2, has the lowest cycle time, 37.25 seconds, followed by design 1, 51.40 seconds. This data shows that the smallest size of runner estimate to be able to save the most time in injection mold process. Obviously, for the short volume of output parameter, design 3 is the winner with 2.7477 cm cubic, and as it has the biggest runner size, while design 2 has the most less with 2.5715 cm cubic, followed by design 1 2.6045 cm cubic. Furthermore, for pressure drop value, design 2 has the highest with 97.81 megapascal, go along with the design 3 that has 79.33 megapascal, and design 1 53.83 megapascal. Shrinkage cannot be avoided in injection mold process. However, the, is- the issue is how much the amount of shrinkage that can be reduced. By saying that, the type of material is not the only factor. The cooling element also must be considered. Based on table 4.1, the result of volumetric shrinkage has been conquered by design 2 with 10.33%, while design 1 and design 3 has 0.25%, and for the optimum volumetric shrinkage is design 3 with 9.967% of volumetric shrinkage. In cooling analysis result, temperature variance and cooling time variance has been measured. For temperature variance, design 3 has the most value, 18.74 Celsius, while design 1, 18.19 Celsius, has the lowest, followed by design 2, 18.22 Celsius. Cooling time variance results, as mentioned earlier, have influenced the cycle time. It is important to consider this result as to improve delivery and product rate of manufacturer. In this study, design 1 and design 2 has the same value of cool time variance with 23.94 seconds, and design 3 has the lowest with 23.87 seconds. To calculate the cost or if actual injection molding process has been made, there is a feature called Cost Advisor in Flow Advisor software. By utilize this feature, cost of the production can be evaluated. Perhaps for this project, we assume to produce 5,000 units of products. Table 4.2, 4.3, and 4.4 below show the cost that has calculated automatically by cost advisor feature in Modflow for design 1, 2, and 3. This is the table for design 1, design 2, and design 3. Based on the discussion in the simulation result and cost calculation section, Group has decided to choose design 1, with width and thickness of runner is 1.25 mm, which is the medium size among the three design. The result of this selection is because this design is stable based on the result obtained. Temperature variance output parameter gain in optimization in design 1. For volumetric shrinkage, design 3 has the lowest percentage, but it was rejected because of the cycle time factor. This design maybe has low shrinkage, but the consideration in terms of economical and saving time is crucial. Although design 2 has the lowest cycle time, the product quality is not as good as design 1. In summary, design 1 is the most balanced and suitable choice. However, the defect of the product cannot be avoided for all three designs because a few reasons when designing the product. The defect is a short when the plastic cannot fully fill the cavity 100%. Moreover, the cost collection shows that the total cost of the production for design 1 is the cheapest.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amirul bin Fazil and my metric number is AD170126. Today I will be presenting for the conclusion of our group. First, the design 1 runner has been the best overall result in injection molding process for our project. Next, it is in trapezoidal shape runner with 1.25 mm diameter. Furthermore, it has low filling time, that is 0.7816 seconds. Other than that, it has lower injection pressure and the shock volume, which is 53.83 megapascal and 2.6045 centimeter cube respectively. And the last one is the cycle time for this runner is 51.40 seconds, but not as good as design 2, that is 37.25 seconds. It has an adequate amount of volumetric shrinkage, that is 10.33%. And lastly, design 1 has the lowest temperature variance, that is 18.19 Celsius. For the recommendation, we suggest that the current design need to be changed to make the product material easier to spread out equally inside the cavities. We need to redesign the shape. We should make the dimension bigger because from the current design, the material can spread fast because it has too small dimension that will pop out short error. We need to check first whether the material dry or not. Thank you.